In this presentation, we will see another form of beta function, which is given by beta m comma n is equal to 0 to infinity y to the power n minus 1 over 1 plus y to the power m plus n dy. This is the another form of beta function. Now we are going to prove this relation. We have beta m comma n is equal to 0 to 1 x to the power m minus 1 into 1 minus x to the power n minus 1 dx. Putting x is equal to 1 over 1 plus y. From this equation we get dx is equal to minus 1 over 1 plus y to the power 2 dy. Also 1 minus x is equal to 1 minus 1 over 1 plus y is equal to y over 1 plus y. From this equation we can write y is equal to 1 minus x over x. From this equation we get, when we put x is equal to 0, we get y is equal to infinity. When x is equal to 1, y is equal to 0. Putting those value in equation number 1. Equation 1 turn out to be beta m comma n is equal to infinity to 0 1 over 1 plus y to the power m minus 1 into y over 1 plus y to the power n minus 1 minus 1 over 1 plus y to the power whole square dy is equal to, because of this negative sign we can flip the limit, lower limit and upper limit. So 0 to infinity y to the power n minus 1 over 1 plus y m minus 1 plus n minus 1 plus 2 dy is equal to 0 to infinity y to the power n minus 1 over 1 plus y to the power m plus n dy. Therefore beta m comma n is equal to 0 to infinity y to the power n minus 1 1 plus y m plus n. This is our required equation. Now we are going to discuss about some important point. If we put m plus n is equal to 1, this gives m is equal to 1 minus n. Beta m comma n is equal to 0 to infinity y to the power n minus 1 over 1 plus y m plus n. This relation going to be, after putting this value 0 to infinity y to the power n minus 1 over 1 plus y to the power 1 dy is equal to beta n comma 1 minus n. Therefore 0 to infinity y to the power n minus 1 over 1 plus y to the power 1 dy is equal to beta n comma 1 minus n. This is very important integration, which is equal to pi over sine n pi. Thank you for watching this video. See you in next presentation.